In this video, you're going to learn some basic vocabulary concerning quadratic functions, as well as be introduced to how you can graph a quadratic function from standard form. Let's talk about some vocabulary. First of all, what is a quadratic function? Well, this is just any function that has the form y equals a times x squared plus bx plus c. Notice these functions have an exponent of 2. This is much different than anything that was linear in the previous chapters. Also, something that's important to note here is that a cannot be equal to 0. A, b, and c, these are coefficients that could be any number, but we do have to be careful. A is not 0, and I'll let you think about why we would maybe not want a to be 0. And if you can figure that out, bring it up in class. It might give you a chance for some extra credit. So, parabola. This is just the U-shaped graph of a quadratic function. All right, so let's take a look at what that may look like on the side here. If we were to make a U-shaped graph, it might look something like this. And that's if it opens upwards. We could also have a U-shaped graph that opens downwards, like so. Similar to when we graphed, if you remember the absolute value functions back in chapter 2, which had a V shape to it. Hopefully you recall what the name of that coordinate was. It's the same name that we give to this lowest point on that parabola and to the highest point of this parabola, and that is called your vertex. So when we talk about the vertex of a parabola, this is just the highest or lowest point on a parabola. Okay, so one other feature that we have here is if we were to take a vertical line and pass it right through the vertex, right about there, we would call that the axis of symmetry because these graphs are symmetrical about that line. What that basically means is that line acts as a line of reflection for these parabolas. So if I were to take this right-hand side of the parabola and flip it or reflect it over that axis of symmetry, it would land right on top of that part of the parabola. This makes it a lot easier to graph and makes these parabolas a little bit more predictable than other polynomial functions that we'll learn to graph in this class. So the axis of symmetry, for now, let's just say this is the vertical line. So we left off with the axis of symmetry of a parabola is a vertical line that passes through the vertex. Okay. When we talk about the standard form of a parabola, this is just what we discussed before, how we defined it. It's just ax squared plus b times x plus c. Notice how we have the x squared term first, the term with the highest exponent, followed by just the x term, and then lastly by the term that is just a number without the variable next to it. When that happens, we call that the constant term, because that does not change, that is not affected by whatever the value of x is, so that's called the constant. Let's go to the next slide and actually start talking about how we graph these things. So, if we want to graph a quadratic function, if it's in the standard form ax squared plus bx plus c, we know it's a parabola that's going to have the following characteristics. The parabola will open up if the a value is greater than 0. It will open down if the a value is less than 0. So that a value, remember that coefficient right there in front of x squared tells us whether it's going to go up or down. Okay? It will also tell us about the width of the graph. If the a value is less than 1, So if it's a number between 0 and 1, it's going to be a narrower graph, and if the a value is greater than 1, it's going to be a narrow graph. So I don't know if I misspoke there. The parabola is going to be wider if the a value is less than 1. It's going to be narrower if it's greater than 1. The x-coordinate of the vertex can be calculated by the following computation. You're going to do the opposite of b divided by twice the a value. And the axis of symmetry is a vertical line that is of the form x equals that value, negative b, over twice a. We're going to put these pieces of information to work in an example on the next slide. In this example, we're going to graph the quadratic function y equals 2x squared minus 8x plus 6 by first noting the values of a, b, and c. When we compare it to the standard form, we know the ax squared plus bx plus c. So just by comparing it, I can see that my a value is 2. And by the way, knowing my a value is 2, I know it's going to open up because it's positive, and because 2 is a number that's greater than 1, I know it's going to be a narrower graph. Excuse me. The b value is the coefficient of x. That's negative 8. And my c value is just positive 6. What I'm going to do now is find and plot the vertex. I recall from that last slide, the vertex, or the x-coordinate of the vertex, is calculated by negative b over twice the a value. Since I have my a and b value written above, I can go ahead and determine the x-coordinate of the vertex by doing the opposite of negative 8 and dividing that by twice the a value, 2. That's going to be positive 8, the two negatives make a positive, divided by 4, giving me an x-coordinate of a vertex, 2. To get the y-coordinate, I'm going to need to take that number 2, that x value, and use my relation, the original equation, to figure out what the corresponding y value is. So let's go ahead and set that up. If I want to know the y value, I'm going to substitute 2 in everywhere I see an x. So it's going to be 2 parentheses squared minus 8 times parentheses plus 6. And I'm going to plug a 2 in here and in there and then simplify, and I'll have my y-coordinate. I'm going to just go ahead and continue my work maybe down here. This term is going to be really 2 times 4, and then this term turns into a negative 16, and then I have plus 6. So I really have 8 minus 16 plus 6, plus 6, and 8 minus 16 is negative 8, negative 8 plus 6 is negative 2. So my y-coordinate is negative 2. That means my vertex at the end of the day here is at the coordinate 2 comma negative 2. What I want to do now is I'm going to go ahead and plot 2, negative 2 on my graph. So I'm going to count 2 over, 2 down, and that is this coordinate right there. That is my vertex. Now, what I'm going to do right away is just dash in a vertical line through the vertex. So it's going to be, that would be like my axis of symmetry. And I'm now just going to find a few more coordinates to plot on this parabola and use symmetry to help me get the other coordinates, and then I'll draw my final graph. To finish this off, I'm going to make an XY coordinate table, and I'm going to pick a few easy x values to substitute into my original function and get corresponding y values. So I can use an easy x value of 0, for instance. If I put in a 0, I'm going to get 2 times 0 squared minus 8 times 0 plus 6. Well, this turns into 0, this turns into 0. I end up with just 6. So when I plug in 0, I get 6, or the coordinate 0 comma 6. I can plot that up 1, 2, 3, 4, 5, 6. That would be the coordinate right there. If I plug in another easy x value like 1, I would get 2 times 1 squared minus 8 times 1 plus 6. 2 times 1 squared is the same as 2. And then I have minus 8 times 1, that's minus 8, plus 6. I know 2 minus 8 plus 6, that's going to be, I think, just negative 6 plus 6. I'll get out 0. So that's coordinate 1, comma 0. 1, comma 0 is right here. Let's see if I can plot this. So I plotted the point. Now I can use symmetry to help me finish this off. I can see if I were to reflect this coordinate 1, 0 over the axis of symmetry, it would land right here at 3, comma 0. Notice how the spacing away from the axis of symmetry is just 1 unit. Similarly, I can take this coordinate and reflect it over the axis of symmetry, and it would land right here, if I have good aim, 2 units away from the axis of symmetry. Notice how the height, or the y-coordinate, is the same. So if I get rid of that circle, I have that coordinate, and now I'm ready to make my U-shaped curve. It's going to start going here through these coordinates, and it's kind of hard with a stylus. Should be a symmetrical graph. Mine's not very good. I kind of have a little bendy part right there. I got to get rid of that if I could write with a stylus better. But nonetheless, that's my U-shaped graph. It's narrow. It opens up. And any coordinate on here is a solution to the original problem. Let's go to the next slide. We're going to do one more together before we exit out of this particular video. We're going to graph y equals negative x squared plus 2x minus 2. First thing that I'm going to do is I'm going to write down what my a, b, and c values are. My a value I know is the number in front of x squared, which is a negative 1. My b value is a 2. And my c value is negative 2. So if I want to get the x coordinate of the vertex, I have to calculate negative b over twice a, which in this problem is going to be the opposite of 2 over 2 times the a value, negative 1. That's going to be negative 2 over negative 2, which turns out to be just positive 1. So right now, I know my vertex is at 1 comma something. I don't know what that is. To figure that out, recall what we did in the last problem. We substituted 1 in for x and got the y value. Let's try that. So for the y coordinate, I'm going to let x equal 1 and substitute it back in. So I'm going to have y equals the opposite of 1 squared plus 2 times 1 minus 2. So I have to square the 1, I get 1, but there's a negative in front, so I get negative 1. Then I have plus 2 minus 2. I think that turns out to just be negative 1. So I now know what the y-coordinate is. It's going to be negative 1. My vertex is the coordinate 1, negative 1. Let's plot it. 1, negative 1, right there. All right, now, what I'm going to do is I'm going to dash in my axis of symmetry, which would be right about there. And now I'm going to pick a couple easy x values. I hope right now you're thinking a very easy x value to plug in is 0. If I plug in 0 for x, I hope you would agree that both this term and this term go away. They would become 0, and I'm left with negative 2. So I'm going to write my x value of negative 2. That's coordinate 0, comma, negative 2. 0, negative 2 is right here. Now, let's go ahead and use symmetry right away and get for free the other coordinate. If I go 1 unit to the other side of the axis of symmetry and plot another point, I would get this guy right there. Another good value of x to plug in might be either negative 1 or not 2 anymore, because I know where I'm at when I'm at 2. I'm at negative 2. But I can maybe plug in 3 if I want. I wouldn't go farther away than that because I might be off my graph. Let's plug in negative 1 for x. If I plug in a negative 1, it's going to be the opposite of negative 1 squared. Let's see if I can zoom in. Then it's going to be plus 2 times negative 1. And then I think it was minus 2. Minus 2. So when I square negative 1, I get positive 1, but there's still a negative in front. So I get negative 1, then 2 times negative 1 is going to be negative 2, minus 2 more. That's going to be a total of negative 5. That's coordinate negative 1, negative 5. If I plot that, negative 1, negative 5, that is right here. So for free, if I use symmetry, that's 2 units away from the axis of symmetry. I'm going to go 2 units to the right, and I get that point. Now I'm ready to make my smooth U-shaped curve going through all 3 coordinates. So it goes like, oh man, bad aim with the stylus. This is going to take practice for me. This is our graph. Notice how it opens downwards. Does that make sense? Let's go back to our original A value. Our A value was negative 1. Do you remember how we said if the A value is negative, it opens down? That's a good thing. We kind of just quick double checked that we graphed this correctly without spending too much time. Thanks for watching.